All right, good day, everybody. Advanced Function class. Trying this video once again. So we're moving on to 1.4, sketching graphs and functions. Just a reminder, I don't have my mask on because I don't have any students in here, and the custodians will be coming around and disinfecting shortly. Okay, so sketching graphs. You'll notice that if you look at the top left corner, it says MCR3U. It's because I'm using my exact same lesson from 11U for my 12U because the content is the same with a little bit more. Okay, so when we have a general function y equals f of x is transformed, it becomes y equals AF. I'm going to write this out. Find my markers. So it becomes y, or f at x, equals AF, let's do square brackets, k x minus d plus c. Okay, so we have the a value, the k value, the d, and the c. The f here represents any function. So f means represent any function. So whether it's a quadratic function, whether it's a cubic function, whether it's a square root function, it's all the same. We could do the transformations for each of the functions the same. So we have our a, our k, our d, and c. Okay, now to go through a little bit of a review, let's go through what a, k, d, and c do to each graph. Okay, so first we have our a value. Okay, so you learn a value in grade 10, and then you touch base on it again in grade 11. So the a value vertically stretches or compresses the graph. Okay, so it's a vertical. Let's do vertical stretch or compress. Okay, so it vertically stretches or compresses the graph. Okay, the a value, so if it stretches if your a value is greater than 1. So if your a value is a 2, 3, 4, 5, 6, 1.5, anything larger than 1 will give you a stretch. And then our compress is anything not just less than 1, but less than 1, but also greater than 0. So any number between 0 and 1, so 0.3, 0.25, 0.5, 0.75, and so on. So from 0 to 1. You notice there aren't any negatives here. We're just looking at the number itself. So even if it's a negative 3, the 3 creates the stretch. Okay? So vertical stretch or compress. Now we add, say, a negative to it. So the negative, if we have a negative value, it reflects the graph over the x-axis. So a reflection over x-axis. So it reflects over the x-axis. Let me see if you can see that. Yes. That glare is not very good. So we have vertical stretch compress. A is greater than 1, it stretches. If it's between 0 and 1, it is compression. If it's negative, it reflects over the x-axis. Okay, now we're going to our k value. So k does a lot like a, except for now it's horizontal. So we have, let me change my color here. We have a horizontal stretch or compress. So horizontal stretch, so we're looking this way. So it stretches or compresses it horizontally. Do remember that the k value, it is the opposite. So if it's larger than 1, it compresses the graph. If it's between 0 and 1, it then stretches the graph. Okay, so it's a stretch if k is between 0 and 1, and it compresses the graph if it is larger than 1. So just because the glare is there, okay, so horizontal, stretch, or compress. So if it's between 0 and 1, it's a stretch. If it's greater than 1, it is a compression. And then note, if it's negative, it reflects over, so if we're going horizontal, it reflects over the y-axis. Reflection over, over y-axis. Okay. You guys can see that. So it's negative, it reflects over the y-axis. Okay, now our d value. Our d value is also dealing with horizontal translation. So moving left or right. Move left or right. If you want to be more correct, you could say it translates to left or right. So we have a horizontal translation. Let me do a different color for that one. So horizontal translation, left or right. Okay, if you just said it moved left and right, I'm fine with that. Okay, so we have horizontal translations left or right. And remember, it's the opposite. So if it's a negative D, it goes to the right. If it's a positive D, then it goes to the left. A quick thing to remember, that anything within the bracket here, the K and the D, deals with horizontal translation. So this is the horizontal stretch and compress. This is the translations left or right. So anything within the big bracket, it has to deal with your X values. Okay, so your X values because it's horizontal. And if it's outside the bracket, like your A and C, then we're looking at our Y values or anything vertical. So that brings us to our last one, which is our C value. So C moves up or down, okay? So vertical translation, up or down. And this is just as you read it. So if it's positive, it goes up. If it's negative, it goes down. If you just said shifts left or right, up or down, I'm okay with that. You don't need to include the vertical and horizontal translations as a definition. Okay. So you guys can always stop the video and copy it out if you need to. All right, so I'm going to erase this. Okay, and we'll go to example 1. All right, example 1. Identify, sorry, tie my shoelaces here. Okay, identify the appropriate values for A, K, D, and C to describe the set of transformations. For the equation here, f at x equals -1/2. Then underneath this root sign is 2 bracket x plus 3. And at the end, subtract 1. So you should have this in your notes already. Okay, so we're going to identify the values and then describe what is happening. Okay, so for our A value, okay, so our A value is the number in front of the bracket or in front of the function. So the function here is the square root. So in front of it is the -1/2, or just, you can write it as 0.5. So -0.5. So what happens, what does that -0.5 do to the graph? What does it do to the parent function? So since it's between 0 and 1, it compresses. So there is a compression by a factor 0.5. So we have a compression by a factor of 0.5. And then we also have the negative value, so then it gets reflected over the x-axis. Okay, so we have a compression by a factor of 0.5, and then since it's negative, it also gets reflected. Okay. So now our next one, so we're looking at our K value. So our K value now is the value outside of the brackets but inside the function. So the number outside of the bracket is the 2, but it's within the function itself, so we have the 2. So our K value is 2. And what does this do to the graph? Well, to the graph, remember, it's opposite. So if it is larger than 1, it compresses the graph horizontally. If it is between 0 and 1, then it is a horizontal stretch. So here it is larger than 1, so this becomes a compression by a factor of 2. So remember, but it's the opposite, so we flip it. So we have a horizontal, sorry, I should have probably said vertical here. So this one is a horizontal compression by a factor of 0.5. So when we're looking at this, remember we flip it over. So it's 2 over 1, we flip it, so it's 1 over 2. Okay, so it's a compression by a factor of 0.5. And there isn't any reflection because it is positive. Okay, now we're going to our D value. So in this case, it is 3, but when we remove it from the bracket, it becomes negative 3. So when we remove it from the bracket, it becomes negative 3. So this is, it shifts 3 units left. Okay, so D is negative 3, so it shifts 3 units to the left. Just gonna give you guys a close-up so you guys can see this stuff a little bit better. There's our A value, our K value, and our D value. Okay, and lastly, we have our C. I'm just gonna put it over here. So our C is at the end, it's negative 1. So we shift down 1 unit. Okay, so shift down 1 unit. So that gets your A, K, D, and C. Let's see if I can move this a bit closer for you guys. Okay, gonna erase that now, and we'll start with number 1. Okay, so it's gonna get cut off here a little bit. Okay, so number 2, transform the function below. So it gives us the original function. It doesn't give us any values, but these are the numbers. So these are the x and y coordinates for this function here, whatever it is. We just made it up. Okay. Then over in the right side here, we took this function, the original function, and we did a whole bunch of translations and transformations to it. So now we have a 2 function, and then brackets negative 2, x plus 3, and another bracket minus 6. So what we want to know is these were the original points. Now we applied all these transformations to these points. What are our new values? Okay, so again, this is kind of like the parent function. Then we are applying all these transformations to the parent function, and now we want to know where are the points now on the graph. Okay, what is the new graph? What is the transformed function? So hopefully you guys learned this last year. Okay, so we could figure out what to do with these points to get to here. Okay, so hopefully you guys learned the mapping formula. I hope this is not in the glare. So the formula is x divided by k plus d. Remember the k and the d affect the x values, what I said earlier. And then to deal with the y's, it's a times y plus c. So x divided by k plus d, and then a times y plus c. Okay, so this is what we're going to do. Actually, I'm not going to write this here. So we're going to plug these coordinates into the formula with the transformations to get our new coordinates. Okay, so our first x, so as our first x is here at 0. So we have 0. Let's see. 0 divided by our k value. So looking over at the formula, our k value is -2. So we're going to divide by -2, and then we're going to add our d value. So our d value is in the bracket. Remember, it's the opposite though. So it's not +3, it's -3. So 0 divided by -2 minus 3. So we don't want to put the plus. So -3, comma. Now we're going to deal with our y value. So our a outside the function, the number outside the function, which is 2. So we have 2 times our y value. So since we use this 0 for the x, we use this one for the y, so it's 6. Plus our c value. So plus c, which is -6. So subtract 6. I'm just going to bring this even closer. Hopefully the glare gets eliminated a little bit. So now we solve this. 0 divided by -2 is 0. -3 is -3. 2 times 6 is 12. Subtract 6 is 6. So this point originally, the 0 and 6, has now got transformed through the stretches, compresses, the shifts left, right, up, down. So this now becomes -3 and 6. So our new transform point is -3 and 6. Let's try another one. We're going to try the next one here.
Alright, sounds good.
So we're changed the 0 into a 2. We're going to use the next point, so 2 and 3. And this becomes 3. Okay, we're only changing the x and the y because their k, d, a, and c do not change. They stay the same. Okay, so now we're transforming the second point. 2 divided by -2 is -1. Subtract 3 is -4. 2 times 3 is 6. Subtract 6 is 0. So our 2 and 3 after the transformations become -4 and 0. Okay, do one more and then you'll see the pattern. So now our last one. I'll do red. So we have 4 and 5. Oh, actually I'll do each one. So 4 and 5. So 4 divided by -2 is -2. Subtract 3 is -5. 2 times 5 is 10, minus 6 is 4. Our transform point is now negative 5 and 4. And our very last one is now 6 and 2. So 6 and 2. 6 divided by negative 2 is negative 3. Subtract 3 is negative 6. 2 times 2 is 4. Minus 6 is negative 2. So our last point is now negative 6 and negative 2. Okay, that is the whole entire lesson for today. I'm going to move this back now. Okay, so that is the lesson for today. It was just sketching graphs of functions. So what we do, if the question now asks you to graph, you just take these points, plug them on the graph, and then we show any continuation with the function. I think that is all. I don't know if I don't think it's listed at the bottom of the homework, so I'm going to write it here. So we have page 35, numbers 1 to 3, 4F, 5CD, 7, 8, 9C, and 10BD. So again, numbers, we'll go backwards, 1 to 2, 4F, 5CD, 7, 8, 9C, 10BD. Okay, hope you guys are doing well, and I'll be online later to answer any questions that you may have. Take care.